Everyone, and today we are going to be doing give me a moment, polynomial factors and graphs. Now, there's not going to be a specific strategy in this one. This is like combining what you know with polynomials with, regular common math stuff and common sense. So, that's it. All right. First one. GZ equals Z minus 1 brought to the power of 5 minus Z minus 1 brought to the power of 4. The polynomial function g is defined above. What is the product of the zeros of g? In other words, find what the zeros are and multiply them times each other, and that's your answer. Pretty simple, I'd say. So the first one is pretty obvious. 1 minus 1 is 0. 0 brought to the 5th power. Oh, well, of course, I always have to butcher the circles, don't I? Okay, this one's a little less horrid. Not by that much, though. Okay. 0 brought to the 5th power is still a super 0. In other words, it's still pretty lame. Yeah, super 0. Still lame. So, that's one of them. So, 1 is one of the things that make it a 0. By the way, I don't know if I explained this. Pretty sure I didn't. Zeros are pretty much what number will make this problem give you 0. That's it. So, now, you guys probably, some of you might not know what the next one is going to be. However, it's pretty simple. It's 2, because 2 minus 1 is 1. And 1 times anything. 1, and since we're doing exponents, whatever exponent you give 1, it's still going to be a 1, because 1 times 1 times 1 times 1, however many times, is still 1. So nothing much has changed. Still a 1. Okay. And 1 minus 1 towards the end, like when there's 2 1s on each side, is just going to give you 0. And 1 times 2 is 2. Easy as pie. Alright, are you ready for the next one? Also, alright, the next one. Polynomial function p has zeros at 3 and 6. Alright, well, hold on. Goodbye, super 0. Okay. What the heck? You were supposed to be gone. You shouldn't have come back. But you did. Okay. At 3... Oh, gosh. Yeah, I forgot to turn the size back down. So forgive me on that one. That thing is wretched. Get it out. Let's try this again. The zeros are at 3 and 6, like I mentioned before. So, judging by needing to get 0, you're going to need some subtraction or some division going on, because there are no negative numbers. So, oh, but what's this? This is the only problem with a minus in it. Now, you could just jump on the ship right off the bat, and it's a pretty good guess, but I guess because this is a math video, I'm going to work it through with you. Hooray for extra work. Alright, But you know, if you want to feel good about the choice and be absolutely super serial safe like me, you're still gonna do it. Alright, so 3 squared is 9, plus 9 times 3 plus 18. Alright, so like I just said, this is going to be 9. 9 plus... wait, no. It was supposed to be a subtraction sign. Go back. Go back. I command you. I gotta do this all over. But hey, you should have done it right the first time. Oh yeah. Okay, so 27, which is 9 times 3, right here. But 9 minus 27, 9 take away 27, is negative 18. And negative 18 plus positive 18 is, whoop-de-doo, a 0. All it is. And the situation works out similarly for 6, on the account that you still get a 0. But that's what we want, so I'm not complaining. So 6 squared is 36, minus 9 times 6, which is 54. Plus 18. Alright, so yeah. Right, 36 minus 54, 36 take away 54, is negative 18, plus 18 is 0. Easy peasy done. So, yeah, that's that one. Could have jumped on this boat from the start, considering none of the other ones were going to get you anything but a positive number, like at all. So, but yeah. Next question. No, that thing is supposed to... I don't even know where the default position is anymore. So I can move this wherever I want. Okay, well, never mind. I'm getting distracted. Next one. This polynomial function h has been defined above. How many distinct zeros does h have? This one just requires a little bit of looking. Not too much of math. Which is cool, right? But, you know, why am I complaining about math in a math video? Because I'm a teenager who kind of dislikes math. It's not like I'm not good at it or anything, but it's boring sometimes. And we'll be right back. Okay, we're back. So, as usual, zeros usually involve you taking one number from another number. In this case, if you ever wanted to decide to... that is the same. So like 8 minus 8. So let's do 8 first. When you put 8 here, it's going to be 8 minus 8. And then you're going to get a 0. Eventually, you're going to put all the other 8s in here. And it doesn't matter what you get. As long as you have one 0, everything's going to end up being a 0 when it comes to multiplication, people. So, I mean, same for the other 4 numbers. So you can just throw 8, 4, 2, and 1 in here, respectively. And you'll get zeros. And that's it. You just had to count these. You didn't even have to go through all of that if you wanted to. But yeah, that's how you get it. You didn't even have to do math on this one. Good job. Why is this thing so big? Right, I left the eraser like this because I'm a silly Billy now. There we go. Better. Alright, next one. Well, I mean, we could just stop here since this is the third math problem, but you know, we're doing math. So, might as well do it all, right? Yeah. Plus more practice for you. Okay, Which of the following equations could represent the graph at the left of in the xy plane? So you got a parabola right here. That's what the U-shaped thing is. It's called a parabola. Let me spell it for you. I believe it is spelled like this. If I'm wrong, blame me. Parabola. Yeah, that's what the U-shaped thing is. Now, you can see that this one clearly drops down. Eventually it does rise up, but first it takes a big poop and it goes up. So it is probably a somewhat sad one. The vertex is at the bottom in the negative zone, because parabolas are kind of like triangles without the third side. That and they're more round. Why am I even rambling like this? Okay, close enough. So let's look at our equations here that could possibly represent this thing. So we got number 1, positive and negative, pretty promising. Number 2, a negative, somewhat promising. Number 3, it's going to be full on positive, so I don't even know why you bother with this one. So this one's an automatic nope. Now, of course, since it rises and falls, it can't be this one, because it's just going to keep falling. And this one is the correct choice. Oh, oops. Now I know there can be negative numbers, but I'm pretty sure there is more to it than that. Okay, so let's go read the rest of the stuff at the bottom, because I'm pretty sure they would know more about this particular problem than I would. So the graph of equation 2 will have repeated zeros. So that means you get 2 different types of zeros when you put in 4. That's an interesting thought. I'm not exactly sure how you do that, but okay. The graph of equation 3 will have 2 negative zeros. Yeah, that's not good. Only one of the equations has a graph that matches the graph shown, which is number 1. So the graph shows 2 distinct x intercepts, meaning it has 2 distinct linear factors. Option 2, which says y equals x minus 4 squared, is incorrect because it has a repeated factor, but not 2 distinct ones. Yeah, so I guess 2 lines can overlap, which would make more sense. So we need 2 distinct options. One of the zeros of the equation is positive and the other one is negative. Oh, makes more sense once again. Also, since the graph changes sign at each of the zeros, passing through the x-axis, the factors must also have an odd exponent, as 1 or 3. Ours doesn't really have any exponent, but anyway, or the one that is the right one. So let me see. Let's see what the zeros in other answer options will be like, using the zero property of multiplication. The zeros of equation, I think this is 1, yeah, equation 1, equal 3 and negative 3, which, since the parabola looks pretty even and it crosses through 2 distinct points rather than 1, I say it counts. Okay, the graph could represent equation 1. The zeros of the third option are 2 and negative 7. Both zeros are negative, so the graph could not represent equation 3. So yeah. So this side is like positive up here and negative on this side, I think. And this one is straight up positive. This one is positive here, negative there, and then this is straight up negative. In case that makes sense, it doesn't make sense, let me pull up a coordinate plane for you. I don't know why I'm spending so much time explaining this, but you know, because I kind of want to. So yeah, this makes more sense, see? Did you get a good look at it? Yeah, I'm pretty sure you did. All right. Well, final one for today. Get out. Get out. And the polynomial above has x minus 5 and x plus 10 as factors. What is the remaining factor? For this one, I had quickly skimmed through the options and did some thinking, and I had realized that 1,000 is the biggest number here, and we should probably focus on how we're even going to get that in the first place. I quickly realized that 50 times 20 does the trick, so these two were out when I figured that out. Then I realized if we had two negatives, the 1,000 would be positive, not negative. That's not what we wanted. So we needed two positives and a negative. And of course, that means we needed one of these, and one of those. Here's a more detailed solution. We know that if we multiply all binomial factors, the final term will equal the product of the second term, including sign of each factor. Let's use x plus t to represent the remaining factor. The final term of the polynomial, we know that 5 times 10 times t equals negative 1,000. 50 negative 50 times t is negative 1,000, and then I'm assuming they divided by 50 and found that 20 was their answer. Easy. And that's all there is for today, folks. Thank you, and goodbye.